In Activity 11, Seeing in 3D, students create the illusion of a three-dimensional object on a flat piece of paper. They use color filters to make a set of glasses that can be used to view three-dimensional images, and then draw a picture that will appear three-dimensional when viewed through the glasses. You will need the following materials from the kit: Activity Sheet 11, Parts A and B, sheets of white paper, index cards, crayons, green acetate, red acetate, masking tape, and the color and light video. You will also need to provide scissors and metric rulers. To prepare for the activity, make a copy of Activity Sheet 11, Parts A and B for each student. From the sheets of green and red acetate, cut a 4-centimeter square of each color for every student. For each team, cut a strip of masking tape 30 to 40 centimeters long. Each student will need 1 square of red acetate, 1 square of green acetate, 2 index cards, and a sheet of white paper. Each team of 2 will need a box of crayons, a strip of masking tape, and a pair of scissors. You may show Part 3 of the color and light video titled Artificial Light to the class during Activity 11, 12, or 13. To begin the activity, initiate a class discussion by asking, how does your brain know how far away an object is? Accept reasonable answers, then explain that binocular means 2 eyes. When we look at an object with both eyes, our brain actually receives 2 slightly different images. Binocular vision enables us to perceive depth and distance because of the differences in the images from each eye. Elicit that monocular vision is sight with 1 eye. Although distances are more easily and accurately determined by using both eyes, it is still possible to do so using only 1 eye. Next, ask students, have you ever read a 3D comic book or used 3D glasses to watch a movie? Many students will be familiar with 3D glasses. Explain that 3D stands for three-dimensional, and that a three-dimensional object is one that has 3 dimensions: height, width, and depth. Inform students that they will make a set of 3D glasses and learn how to create their own three-dimensional images. Divide the class into teams of 2 and distribute the materials. Give each student a copy of Activity Sheet 11, Part A. Have the students follow the instructions on Part A of the activity sheet to make a set of 3D glasses. Make sure the filters are positioned properly in the eye holes of the glasses. Then staple the students' glasses through the filters and close the cut that the students made to cut out the eye holes. The students should cut out the nose piece after the glasses have been stapled, as they will probably have to cut through some of the filter. When they have finished, encourage students to use the glasses to look around the classroom and describe what they see. Students may notice that some things, particularly colored images or crayons, appear to be displaced. This is because each eye is receiving different information about the color of each object. Next, distribute a sheet of white paper and a copy of Activity Sheet 11, Part B, to each student. Have them follow the instructions to trace the figures, 1 in red and 1 in green, and to overlap them according to the alignment of the black dots in the figures. Have the students look at their pictures through the glasses. Most students will report seeing some sort of depth or images coming off the page. What they are supposed to see is an overhead view of a square pyramid with the top cut off. Then ask students, how does looking through the glasses make a flat picture look three-dimensional or like a real object? The students probably will not know. Have them hold a crayon an arm's length in front of them so that it points toward 1 eye. Tell them to cover 1 eye, then the other eye, and do this repeatedly. Ask students what happens when you look at a real object, first through 1 eye and then the other. They will see that in one view it seems to point right at the eye, but in the other view It seems to point slightly to the left or right. Explain that one way people tell how far away objects are is by how different they look through each eye. Next, ask students, why do you think you put red and green lenses in your glasses and drew pictures with red and green crayons? Students should understand that red crayon cannot be seen with red lenses, and green crayon cannot be seen with green lenses. Have them look again at their pictures through the glasses, this time covering one eye at a time. Then have them open both eyes and ask students, if each lens makes each eye see only one picture, why do you see 3D when you open both eyes? Through the red filter in the right eye, the red lines disappear and the green lines become darker, forming a flat image that looks like the top figure in Activity Sheet 11, Part B. Through the green filter in the left eye, that figure disappears and the red lines of the bottom figure of the activity sheet become darker. Finally, ask students, would other color filters or crayons have worked? Students could have used any colors as long as the filters were the same colors as the crayons. They used red and green because they are the most effective filter colors. To conclude the activity, you may want to let students keep their 3D glasses for personal use, as they will not be needed again in this module. Return the video to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.